Meta-analysis combines results of multiple studies to identify trends and overall effects. It provides a comprehensive understanding of a topic, especially valuable in fields with conflicting results. Meta-analysis clarifies discrepancies and offers robust conclusions. Essential for evidence-based practice in research and policy. Aggregated data aids informed decisions. Increases power to detect effects missed in smaller studies. Mastering meta-analysis can seem daunting but is rewarding. Selecting a topic is the first and crucial step in conducting a meta-analysis. Your topic should be both interesting and researchable. Identify gaps in the current literature or areas with inconsistent results. Read recent review articles or meta-analyses in your field. Focus on specific questions rather than broad ones. For example, study the impact of digital learning tools on high school students' performance in urban India. Ensure there is enough existing literature on your topic. Conduct a preliminary search to see if there are sufficient studies to analyze. Discuss your topic with your advisor or peers for feedback. With a clear, focused research question, you are ready to move to the next step. Gathering relevant literature requires thoroughness and patience. Identify key databases in your field. Use specific keywords and Boolean operators to refine your search. Screen titles and abstracts to determine relevance. Obtain full texts for a detailed review. After gathering the relevant studies, the next step is data extraction and coding. Systematically collect and code necessary information for analysis. Use forms or spreadsheets to organize this process. Extract key information like objectives, methods, and results. Note variables affecting outcomes, such as demographics. Detailed information is crucial for meta-analysis accuracy. Categorize information to make it comparable across studies. Code interventions and outcomes consistently. Develop a coding manual for consistency. Double-check data and coding to minimize errors. A second review can enhance reliability and ensure accuracy. Section 5. Analyzing the extracted data. Once the data is extracted and coded, it's time to analyze it. Meta-analysis typically involves statistical techniques to combine and compare results from different studies. Commonly used software for this purpose includes comprehensive meta-analysis, RevMan, and R. Begin by calculating effect sizes for each study. Effect sizes provide a standardized measure of the impact of an intervention, making it easier to compare results across studies. There are different types of effect sizes, such as Cohen's D, Hedges G, and correlation coefficients, depending on your data. Next, use meta-analytic models to synthesize these effect sizes. Fixed effects models assume that all studies estimate the same underlying effect, while random effects models account for variability among studies. The choice of model depends on the heterogeneity of your data. Conducting sensitivity analyses can also help assess the robustness of your findings. This involves testing the impact of excluding certain studies or using different assumptions in your analysis. Section 6. Interpreting results and drawing conclusions. Interpreting the results of your meta-analysis involves more than just reporting statistical findings. It requires a nuanced understanding of what these results mean in the context of the broader literature. Start by summarizing the main findings, including the overall effect size and any patterns observed. Discuss the implications of these findings for theory, practice, and future research. For example, if your meta-analysis shows that digital learning tools significantly improve student performance in urban India, consider what this means for educational policy and classroom practice. It's also important to acknowledge the limitations of your meta-analysis. These might include biases in the included studies, limitations in the data extraction process, or the generalizability of your findings. Being transparent about these limitations strengthens the credibility of your work. Finally, provide recommendations based on your findings. These might include suggestions for future research, practical applications, or policy changes. Summarizing your conclusions clearly helps ensure that your meta-analysis has a meaningful impact. Section 7. Common tools and software for meta-analysis. Several tools and software programs can facilitate the process of conducting a meta-analysis. Understanding the strengths and limitations of each can help you choose the best one for your needs. Comprehensive meta-analysis is a user-friendly software that offers a wide range of statistical options and graphical outputs. It's particularly useful for beginners due to its intuitive interface. RevMan, developed by the Cochrane Collaboration, is another popular choice. While it's primarily used in healthcare research, its robust features make it suitable for education and social sciences as well. It includes tools for data extraction, risk of bias assessment, and various statistical analyses. For those familiar with programming, R offers powerful packages like Meta and Metaphor for conducting meta-analysis. These packages provide extensive customization options, but require a steep learning curve. Choosing the right tool depends on your specific needs, the complexity of your data, and your comfort level with statistical software. Section 8. Examples related to Indian education. To illustrate the process, let's consider a meta-analysis on the impact of digital learning tools on high school students' performance in urban India. This topic is both timely and relevant, given the increasing use of technology in education. Start by gathering studies from databases like ERIC, PubMed, and JSTOR, using keywords such as digital learning, India, high school, and urban. Screen the studies based on inclusion criteria like recent publications, focus on digital tools, and relevance to high schools. Extract and code data from selected studies, noting variables such as the type of digital tool used, the duration of the intervention, and the measured outcomes. Analyze the data using software like CMA or RevMan to calculate effect sizes and synthesize results. Interpret the results to understand how digital learning tools impact student performance. Discuss the implications for educational policy in India and provide recommendations for future research. Section 9. Examples related to Indian social issues. Another example could be a meta-analysis on the effectiveness of community-based interventions in improving mental health outcomes in rural India. This topic addresses a critical social issue and has a wealth of existing literature. Use databases like PsycInfo, PubMed, and JSTOR to find relevant studies. Keywords might include community-based intervention, mental health, rural India, and outcomes. Screen for studies that meet your inclusion criteria, such as those conducted in rural settings and focusing on mental health improvements. Extract and code data, noting variables like the type of intervention, duration, and specific mental health outcomes measured. Analyze the data to calculate effect sizes and synthesize findings using appropriate statistical models. Interpret the results to understand the effectiveness of these interventions. Discuss the broader implications for mental health policy and practice in rural India, and provide recommendations for future research. Section 10. Practical tips for beginners. For those new to meta-analysis, here are some practical tips to make the process smoother. First, start with a well-defined research question. This will guide your entire process and ensure that your work is focused and relevant. Be thorough in your literature search. Use multiple databases and a combination of keywords to ensure you capture all relevant studies. Keep detailed records of your search strategies and inclusion criteria to maintain transparency. Develop a clear coding manual to ensure consistency in data extraction. Double-check your data and consider having a second person review it to minimize errors. Finally, choose the right software for your needs. Whether it's CMA, RevMan, or R, make sure you are comfortable with its features and capabilities. Section 11. Conclusion. Conducting a meta-analysis in education and social sciences can be a complex but rewarding endeavor. By following a structured approach, you can synthesize existing research to provide more robust conclusions and inform practice and policy. Start with a clear and focused research question. Gather and screen relevant literature using specific databases and keywords. Extract and code data systematically and use appropriate software to analyze it. Interpret your findings in the context of the broader literature and provide actionable recommendations. With practice and attention to detail, mastering meta-analysis can significantly enhance your research skills and contribute valuable insights to your field. Happy researching!